vectors, we're going to look at the magnitude and direction. Here we go. In the blue box, we can see that there is a vector. I'm going to zoom in just to point out a few things here. Okay, looking at this blue vector, the length of the vector is the magnitude, and we're just going to create a right triangle and use Pythagorean theorem to find that magnitude. Okay, the direction is a little bit different. The direction is found by, most often you're going to use tangent. So the tangent of that angle theta is equal to the opposite leg, in this case it'll be the b value, over the adjacent leg, in this case it'll be the a value. Okay, and then to find the theta, we would try to do the inverse of tangent so that we got the theta is inverse tangent of that ratio. Okay, and at that point you may need to use a calculator unless it's one of the special angles that we already know about that's on the unit circle. Another trig function that I use sometimes, if I know that my angle is over in quadrant 2, I might use the cosine of theta, okay? Because when I end up doing the inverse cosine, it will put me, or it'll return rather, an angle in quadrant 2. So something to think about, not something you're forced to do. It may come up in some of our examples, and we'll address it then. Okay, so let's look at 2 examples here. First one, find the magnitude, which is the length, and the direction, which is the angle. Okay, for the vector, so I'm just notationally, let's say it's vector v. The magnitude represented that way, and the direction is going to be the angle. Okay, with the initial point at -8, 1, and terminal point at -2, -5. I'm going to plot this also, and I'm going to plot it as we go. I like to just have a visual of what's going on. I recommend it. Oops, I want to change colors, but my calculator function's not letting me change. Okay, well, we're riding with it today. -8. 1, 2, 3, 4, 5, 6, 7, 8. There's -8, +1 right there. That's the initial point, P. And the terminal point is -2, -5. So there's -2. 1, 2, 3, 4, 5. There's my -5 mark. So -2, -5 right here. And this is my point Q. So this is my vector that we're talking about. I am going to use Pythagorean theorem to find the magnitude. And basically, I'm going to generate a right triangle out of this, right? So if here I'm at -2, and here I'm at -8, that means that this is 6 units long. And if here I'm up at a height of 1, and here I'm at a height of -5, then this is also a length of 6. So the magnitude of this vector is, well, Pythagorean theorem, right? 6 squared plus 6 squared equals the length of the hypotenuse squared. So we'll have to square root it. So we will get 36 and 36, so 72. Or if I said that's just 36 times 2, I could now say that the magnitude of vector v is 6 root 2. Okay, so there's my magnitude. Now let's talk about the angle. Okay, the angle is, one thing to think about is, if I were to pick up this vector and move it, it is going, like, let's say we write it as a position vector, right? In other words, if I add 8 and drop it 1, my start would be at 0, 0. My end would be at 6, -6. And that would be the position vector. So 1, 2, 3, 4, 5, 6, -6. So this is it written as a position vector. Position vectors was a previous video. Okay, so if you think about the vector on the origin, right, starting on the origin, the angle is this one. Okay, now you wouldn't have to have slid the vector over there, you could find that angle right here because it's basically starting from a horizontal, like positive x-axis horizontal, and rotating downward. So this is going to be our angle theta, okay? Now, I'm going to use tangent and say, okay, well, the tangent of theta for this is going to be opposite over adjacent. In other words, tangent of theta is equal to -1. Grab your calculator, degree or radian mode, whichever you prefer, inverse tangent on both sides gives us a theta value of -45 degrees. There's the direction and there's the magnitude, okay? Next example, show that the vector with the initial point 5, -3 and terminal point -1, 2 is equal to vector u with an initial point -1, -3 and terminal point -7, -2. Okay, holy smokes, two vectors here. We have a vector v and a vector w, okay? Vector v has an initial point, I'll call it I, of 5, -3. It has a terminal point, I'll call it t, of -1, 2. Now, if I wanted to write this as a position vector, I would want the initial point to be 0, 0. So I would move it to the right 5, excuse me, I meant to the left 5, and I would move it up 3. So now the starting point is 0, 0, like so. And the ending point is -6, this was a 3, 5. And I'm going to put the sharp brackets on it because that's how we indicate that it's a position vector, meaning it starts at 0, 0, and that's where it ends. All right, the second vector that we're looking at has an initial point, we'll call it I, of -1, -3, and a terminal point, we'll call it T, of -7, 2. Same thing, I'm going to change it so it's a position vector. So I'm going to slide it right 1 and up 3. So if you move the first point that much, you have to move the second one. So right 1, up 3. So now it starts at 0, 0, and it ends at -6, 5. If they have the same position vector, that means that vector v and vector w are the same length and are point in the same direction. Okay, remember vectors are line segments with a direction. Okay, so I'm going to come over here and I'm going to show you vector v and vector w, and then I'm going to show you the position vector that we just proved that they're both equal to. Okay, so 5, -, I'm going to go to vector v first. Okay, 1, 2, 3, 4, 5, -3, 1, 2, 3. This is the first coordinate point. T, -1, 2. So this right here in this direction is vector v. Okay, now let's go to vector w. Vector w starts at -1, -3, and vector t is -7, 1, 2, 3, 4, 5, 6, 7, and +2, 1, 2. Okay, you should notice, whoops, other than I'm not a very good straight line drawer, that they are the same length and point in the same direction. As a position vector, it is -6, 5 that they are both equivalent to. So 1, 2, 3, 4, 5, 6, there's my -6 mark, and up 5. 1, 2, 3, 4, 5. So from the origin, because that's where position vectors start, that's the vector. Okay? Next about that, so this one was u, this one was v, and then that was the position vector. Next it says find the magnitude and direction. It doesn't matter which vector you do it with because we can pick up vectors and drop them wherever we want them. So these vectors here can all just be picked up or not, picked up and moved. Okay. So suppose we're looking at this vector, -6 up 5. This one right here, okay? This side is -6, this side is 5, and we want to know the magnitude. So magnitude of this vector, I don't have a letter for it, so I'll call it P for the position vector, is equal to if one leg squared, right triangle, right leg squared plus another leg squared, a squared plus b squared equals c squared, so 50, 61. So the square root of 61 is the magnitude. Okay, now let's talk about the angle. This is in quadrant 2. If I use tangent and then do an inverse tangent, it will return me an angle down in quadrant 4. It's going to give me a negative angle because it thinks I'm talking about this one down here. Okay, so you can use inverse tangent, but if you get a negative angle, you need to know that it's actually in quadrant 2, so you need to add a 180-degree rotation to it. Okay, if you want to try to avoid that, you could use cosine. So cosine, remember when we do inverse cosines, it returns in quadrant 1 and 2. So cosine will be a -6, which is adjacent leg over hypotenuse. Inverse cosine will produce an angle of 140 degrees. Well, let's go 19 degrees. Okay. All right.